Good afternoon, everyone. My name is Nick, and I'd like to welcome you to another talk in our series sponsored by Bracklet. Today, we have the pleasure of welcoming Micah Ziegler to give us a brief talk on testing. So without further ado, I'd like to pass it over to you, Micah.
Thanks, Nick. Good evening, everyone. Thank you all for attending tonight's event. Before we get started, I want to thank Bracklet for sponsoring this tech talk. Like he said, my name is Micah Ziegler. I'm a software engineer, and tonight we're going to be diving into testing. I'm going to present 3 best practices when it comes to writing meaningful tests so that you and your team can produce scalable, maintainable code, and you can achieve test coverage that actually matters. We may run into some bonus best practices along the way, and then to close the night, we'll take a look at a couple options you have when it comes to testing libraries. So let's get into it. The first best practice answers the question, what should you test? And the answer is pretty simple. Test what the code does, not how it does it. In other words, test the evaluated results, the outcomes of your code, what the user is going to see externally. Testing specific implementation makes the test fragile. So a good rule of thumb is to assume that someone else is going to write the code that you are testing. Let's say developer A, Greg, is on the testing team and Michaela, dev B, is on the backend team. And they have 2 entirely different approaches to the problem. Both approaches will achieve the same desired result, but if Greg writes a test for himself, according to the specific implementation he has in mind, that test will likely fail when Michaela writes her code, even though it works. Testing only the results allows for diverse approaches. So let's take a look at an example. Here's a simple algorithm. You have an unsorted array of numbers. If a number appears twice and only twice, return that number. Okay, that's pretty simple, pretty straightforward. So let's declare a function and we'll instantiate an empty object for our cache. And we use a for loop to iterate through our array and a ternary to put those elements into our cache with a value of 1 or 2. And then we return the array element that has a value of 2 in the cache. Fantastic. So let's test it now. As you can see, there are only 3 lines of code for this specific test, and really only 1 line that's actively doing any work, line 11. Testing implementation would require a lot more code. It's going to be confusing and time-consuming. Here, we are only looking at the evaluated result. That's it. That means the developer could use a nested for loop, double pointer design pattern. They could sort the array and check adjacent elements, or they could take a totally different approach. As long as their code works, this test will pass. And you may have noticed that we are testing a different array than what's consoled in our main file. And that's our first bonus best practice. Give yourself as large a sample size as possible. If you need a new test, use a new data set. It's very simple, but this will strengthen your code by testing it under different circumstances. So now what? We have code that works and a test that passes. Should we move on, or is there something missing? Well, that's our second best practice, which is about how you should test. What's the best process for making meaningful tests? Another simple answer, make it fail. It is impossible to know if a test is working the way it should unless you see it fail. I'm sure you are all familiar with this diagram. It's known as a test-driven development process where you write a test first, then you write code that makes it pass, and then you clean up and move on. But no matter where in the development process you write your test, you still have to make sure it fails. So with that in mind, I actually added a step to this diagram. Step 2.5, break the code. Ask yourself, will my test pass even when it shouldn't? It's in this space of development where you can actually kind of play and have fun. So that's another bonus best practice. Have fun with your tests. It's difficult with a simple algorithm like we are working with today, but with more complicated code bases that you'll be working with and testing on the job, you can really explore and find connections by tinkering with your tests, and you'll learn a lot in that process. So let's get back to our test. It's a simple code and a straightforward test. So first, I'm just going to make sure that it fails when it should. I'm going to remove the second 3 from my test array so there's no duplicate. And it fails. Great. But is there another scenario where my test passes when it shouldn't? Right now, neither my code nor my tests are considerate of edge cases. And as a rule of thumb, you shouldn't assume the developer is going to write appropriate edge cases. Instead, make sure that they have to by writing tests that fail without them. So let's go back to our test suite here. I've added in a test for the 0 duplicate scenario and a test for the triplet scenario. And thinking of that test actually led me to add a triplet to the first test, it's an extra 7, just to make sure that it only returns a duplicate 3. And there's one more scenario that's not accounted for in these tests, and I left that out purposefully so you can try to guess what it might be. What if I have 2 different duplicates? Which one should I return? Both of them, the first one? Our prompt doesn't really specify, so we'd have to communicate with the team to determine the goal of our function and test accordingly. But those are the kind of questions you should be asking as you test your code. We also have another bonus best practice here. Write your tests as if they were documentation, because in reality, they are. The test files for a code base are an incredible resource, or I should say that they can be an incredible resource. For anyone who's trying to onboard your project, as well as any people in the community looking to contribute, the test suite can directly tell developers, this is what the code should do. This is what should happen when this feature runs. I could write these tests in shorthand because I know what they're doing, but it's just like pseudocode. Write your test suite so that anyone can look through it and understand what's going on. So I go through and I run these new tests, and luckily they fail. So I go back to my code and I refactor until my test passed. I changed my ternary operator to increment so that triplets are correctly accounted for. And I moved my return statement out of the for loop because before, as soon as one element was repeated, the function would return right then, even if there are more repeats later in the array. So this handles that scenario. I can run my test suite again, and they all pass with my new code. So we've gone through this test development cycle, and now we can refactor and move on. And that brings us to our last best practice, which focuses on when you should test. And I set this up as the last point tonight because it's kind of a trick question in that there isn't a definite set answer. As long as you write good, meaningful tests, it doesn't really matter if you write them before or after you wrote your code. So instead of telling you if TDD is the best paradigm, let me present you with a problem and a potential solution for each approach. The problem with testing after you write your code is the potential to fall into the code works trap. If the code is written and the code works and you're approaching the project deadline, testing is not going to feel very important. You'd much rather work on another feature or sprucing up the UI or cutting down on time and space complexity. So there's a strong chance that you write a test, and if it passes, you just move on without digging any deeper. And in the worst case, you may be approaching a deadline and have a test coverage metric that you have to hit. So you write tests that pass just to hit that mark. And that kind of coverage is actually meaningless. Dr. David Rodenas and one of his students actually created a library that meaninglessly covered 85% of a code base. So don't be fooled. The idea that anything is better than nothing is not necessarily true here, because how likely is it that you or any other developer are going to go in and rewrite tests for a part of a code base that is already covered? Much better to not touch the code with a test, so you have to address it later. So how do you avoid this trap? Well, you commit to our second best practice. You do not move on from a test until you've seen it fail and you've thought about those false passes. That will keep you out of this trap. Now, the problem with testing before you write your code is that it's frustrating and it requires patience and it feels like it slows down the development process. You've gone through research and design. You just want to put your fingers on the keyboard and make progress. And it is true, this can slow you down, especially the first couple of times you really try to implement the TDD paradigm. However, you will get faster as you get used to working this way. And if you do have a test coverage metric, then I highly encourage TDD because you're more likely to hit that mark in a meaningful way, because testing will be a part of your MVP and your process from the beginning. And the trick to make this method more bearable when you start is to write the smallest test possible that gives you an excuse to write the code you want. And it sounds really intuitive, but really think of this as a part of your workflow. You want to work on a feature, so create a feature branch, add a test suite for that feature with just one test, write code for that one test, commit, add a test, write code, commit, and repeat. You do not have to write 100% of your tests before you start to write your code. Just start with the smallest piece that gives you an excuse to write the code you want. And that's it. Those are the testing best practices I have for you tonight. So now let's take a minute to look into some testing libraries that are available to you and your team. We're just going to be thinking about unit testing tonight. I could jump into a whole other tech talk about the testing pyramid and the infrastructure you should bring for unit and integration and end-to-end testing, but we're going to keep it simple for the sake of time. First, the biggest piece of advice I have for you is to choose a library that's built to be semantically written, because it will help you with that bonus best practice to write your test like documentation. You have plenty of options, so do yourself a favor and choose a semantic library. Now, here are a couple of graphs that I pulled from the State of JS website, which is a fantastic resource for learning about what's growing and trending anywhere in the JavaScript ecosystem. These are from their testing surveys with over 19,000 participants. This first graph on the top is tracking usage. No surprise, Jest is the most used library for JavaScript by a significant margin, and for good reason. I used Jest for our earlier examples, but I want to draw your attention here to this green line. That's Vitest, which was released in December of 2021. So that mark barely even counts, and these are the 2023 survey results. So in just 2 years of availability, Vitest jumped up to 34% usage. And this bottom graph is about retention. So people that use the library and said they want to use it again. Vitest came out on top with 96%. Clearly, Vitest is worth looking into. So let's compare it to Jest a little bit. You may have guessed it. Vitest was built to be compatible with Vite for unit testing. Before Vitest, there was some duplicate configuration and duplicate pipeline confusion required to be able to use Jest with Vite projects. And that just added some unnecessary complexity. So Vitest was created, and they built it with an emphasis on speed. It does have an API compatible with Jest, so it can be used as a one-to-one replacement for most projects. And it still supports mocking and snapshots like Jest does. But there is a little bit of extra setup if you're using Vitest on non-Vite projects, whereas Jest is built to be implemented simply into a broad spectrum of projects. Now, if your project is built with a specific module pattern, that may influence your choice of library. Both of these can be configured for use with either CommonJS or ECMAScript, but they are built to be compatible out of the box with their specified patterns. The biggest deciding factor is probably going to be this last point. Vitest is growing in popularity, which means its community is growing, but it's still far behind Jest in this area. Jest has been around for so long, if you're having a problem, someone else has already had that problem, and there's probably a solution out there for you. The Vitest docs are pretty robust, but the community around it just isn't as expansive. Vitest, however, is beating Jest when it comes to speed, which is what they set out to do. One developer tested both libraries on his project and found that Vitest ran through the test suite over 4 times faster when live testing while he edited a file. So both of these libraries are going to be solid options for you to unit test a JavaScript project. And it really just comes down to what's going to work best for you and your team and your project. Thank you all for joining me tonight. Here are my works cited. And if you have any questions, please reach out to me on LinkedIn. I'd love to break code with you. And thank you again to Bracklet for sponsoring this Tech Talk. Good night.
Wow, Mary, that was fantastic. I did not know that about the speed difference. That is awesome. And really good explanation of a lot of testing best practices. We have time for 1 or 2 questions if anybody would like to call in. Let's go. Colin, what's your question?
My question, Micah, thank you so much. That was really helpful. I have iterated over a few projects, and I am kind of confused sometimes as to how to implement tests over someone else's project. And I'm wondering, is there some kind of strategy or advice that you have for us regarding that?
Sure. Yeah. Thank you, Colin. I appreciate that. When you take on an iteration project, I think the best way to think about it is you're taking on a new project and you're thinking about improving it, right? So you're looking at specific pieces of code in that base that you want to work on. So if they don't have a test suite, you can kind of use that as a base of like where you should implement tests, because after code is written, testing isn't so much about helping the build process as it is about making code more stable, more maintainable for the future. So if you're looking at a project and you want to iterate on it and you want to build on top of it, that is proof that those are areas of the code base that should be stable because other people are going to work on it and want to develop and want to iterate. So it's a really good place for you to add testing. And I also think it's a great opportunity for you to implement the TDD paradigm because you can, yes, the code's already written, But because it's on a smaller scale, like the adding features that you're going to be working on, you can kind of get your feet wet with TDD if you haven't done it before. It's a good way to introduce yourself to that. And if you write tests, you can then check, like, does the code fulfill those tests? The code that's already there, like, does it fulfill the tests that I've written? So I think those are two ways, like trying to implement TDD and really focusing on tests for the parts of the code base that you're interested in working on.
Great, thank you.
Yeah, for sure.
Anyone have one last question? Oh, Felipe.
Yeah, hi Mike. Great talk, man. My question is, I guess, a bit of a nuanced one. So, for testing, I guess it's something that could be sometimes perceived as boring by some people. And would you suggest that maybe it promotes being creative, and it could be something that, you know, it's fun to do? And if so, why would you think that's?
Yeah, for sure. Thanks, Felipe. I appreciate that question as well. I mean, I really enjoy testing. I have fun with it. I think the way to make it fun is to really explore in how you can break the code with your test and break the test itself. How can you make it fail? Because that's really how you can dig into the nitty-gritty of your code and find those connections. It's a great comic I found. Dr. Rodenas actually like created that comic for one of his articles, and it's a great representation. Like, it is a great way to figure out how code works by figuring out, like, will it break if I do this? But yeah, I totally understand. Like, part of it seems like, oh, it's boring. I want to make something that is productive that the user is going to see. But yeah, testing is a great opportunity to learn and to really like actually play with code.
Yeah, absolutely. Thank you so much.
Yeah.
So great questions and answers. Micah, thank you very much for that talk, and thank you everyone for coming out. We'll see you at the next one.